Hello everyone, this is Avijit Sharkar from Group F, and today we are presenting our project titled AI-based personal protective equipment compliance solution for the construction industry. This project addresses a critical and persistent challenge in the construction sector, ensuring consistent and accurate compliance with personal protective equipment or PPE requirements. Why does this matter? According to 2023 construction industry safety statistics, there were 1,034 workplace fatalities, and a disproportionate number of total deaths occurred in construction industry. Notably, 30% of OSHA violations were related to PPE non-compliance, and 20% of all workplace deaths were linked to poor safety practices. This clearly signals that our current safety systems are not sufficient. PPE compliance remains a significant and unresolved issue that demands immediate and scalable intervention. Why AI? Manual safety inspections have serious limitations like delayed intervention, limited monitoring, and inconsistent coverage. These gaps result in 37% injuries due to PPE misuse, 63% difficulty in PPE compliance, and 70% missed PPE violations, with an annual labor cost of over 52,000 US per project as reported by OSHA. AI offers a promising alternative. It enables real-time intervention, simultaneous multi-site monitoring, and most importantly, consistent safety surveillance, all of which manual methods struggle to achieve at scale. So, what do we propose? We developed an integrated AI-based solution comprising three core modules. PPE detection. Using YOLO V5, a state-of-the-art object detection algorithm, we can detect safety gears like helmets, gloves, and vests in real time. Face blurring. With OpenCV, we ensure privacy compliance by anonymizing workers' identities during surveillance. Safety reports. Leveraging ChatGPT, we generate detailed natural language safety reports summarizing PPE violation, inspections log, and compliance status. Together, these components provide a scalable, non-intrusive, and intelligent compliance system suitable for dynamic construction environment. To conclude, this AI-based PPE compliance framework not only helps reduce accidents and deaths, but also provide a cost-effective and scalable solution to long-standing challenges in the construction industry. Thank you everyone for your attention. I am now handing over to Shuzan for the next part.
Hello everyone, so my name is Susan Gewali and today I'm going to present our first AI solution that we proposed, that is PPE detection on the construction side using the YOLO version 5 model. So after doing a lot of literature review, we finalized the CSPG dataset, which consists of 1699 images. So these images include air safety related classes such as helmets, vests and the glasses, which were all relevant to the personal protective equipments. So the dataset was originally in the Pascal Coco format, so we have to convert it into the YOLO format, which is what our detection model expects. So after that, we split the dataset into 80% is training, 10% validation, and 10% testing. So but before training we had to make some changes, like the original dataset was incomplete, especially when it came to the head class. So some head classes were not labeled at all, which could confuse the model during training. So to fix this, we use the RoboFlow, which is the online tool that helps with the image annotation and the dataset management as well. So we manually annotate the missing labels using RoboFlow, and this really helped make the dataset more complete and robust. So after that, we have like 1,359 training images and 170 validation and 170 testing images. So if you look at this table on the right, so you'll see the list of class IDs and the class name. So we mapped 0 to the blue helmet, 1 to the glass, 2 to the head, and so on. So let's move to the next slide, which is about training our model. Now let's go over how we trained our object detection model using LOV5. First of all, why LOV5? It has a very high accuracy and it is very lightweight model. It is very good for real-time detection performance, which is crucial for live construction site monitoring. It's also very easy to train and customize, and it's beginner friendly. So that was the another reason why we use LOV5. It has the strong community and well documented resources, which makes troubleshooting and implementation much easier. So for training, we use the following hyperparameters. So we use the epochs of 12, batch size of 13, and image size of 640 by 640. So usually this is the standard format that is widely used for training the model. So on the right hand side we can see the bar graph. So you can see this is the performance matrix for each classes. So each color represents a different metrics, like blue color represent the precision, red represent the recall, and green represent the MEP, which is means average precision. So from this chart we clearly see that the portion and the yellow helmet are the top performing classes with high score across all metrics, basically like for precision and recall. So on the other side, like blue helmet and the glass didn't perform so well. So it is likely due to the fewer annotation or more challenging visual features. Actually we have only few images with the glasses in our dataset, so that might be the reason that model cannot read the pattern. So it is not performing well in case of glass. So on this slide we are showing the results from testing our trained LOV5 model on a video. Basically we ran the model on the real construction site footage to see how well it could detect different objects in real time. So as you can see in the frame on the right, the model picked up on multiple classes like a person, their helmet, and the safety vest, and even we can see the confidence score over there, which is pretty good. This shows model is not just working, but working with a decent level of accuracy. So the detection ran at the rate of 30 frames per second, which means it's like fast enough to be used for live video monitoring. So overall, it demonstrates application in the safety compliance monitoring and reduce the need for constant, manual oversight. Thank you.
Thank you, Sujan, for detailing the PP detection part. Hello, everyone. My name is Aranya Paul. In this part of the presentation, I will walk you through our phase blurring solution using OpenCV integrated into PP detection, or we can call it PP anonymization. When using vision systems on job sites, we often capture workers' faces while monitoring PP. This poses privacy concerns. To address this, we have implemented a face and region anonymization module that helps ensure legal compliance and supports ethical AI use. This chart shows how the blurring module decides what to anonymize. It starts by reading the YOLO label file and checking for these classes, head, glasses, and helmet. If the head is detected, it applies a blur there. If not, it falls back to blurring either the glasses or helmet. This ensures that every frame has at least one identifiable region blurred before output. Let's go into some details of the detection and label extraction. After parsing the labels, the coordinates for each detection are converted from normalized values to actual pixel positions using the image's width and height. We extract bounding boxes corresponding to heads, helmets, and glasses based on the class IDs from EULO version 5. The key logic here is prioritization. The system always tries to blur the head first. If that's not detected, it checks for glasses or a helmet instead. This way, we ensure that some form of a privacy protection is always applied even if the face isn't perfectly detected. Once the region to blur is selected, we apply a strong Gaussian blur using OpenCV. The blur is applied only within the region of interest, so the rest of the image, including PPE like vests or gloves, stays fully visible. We use a large kernel size like 55 by 55 pixels and a high sigma to ensure full masking of the face or helmet area. This selective blurring allows us to anonymize sensitive features while preserving all the context needed for PP compliance tracking. In addition to images, the script supports full video anonymization. It processes each frame individually, loading the corresponding YOLO label file, determining which region to blur, and applying the same logic we use for still images. The result is a video where sensitive features like faces or headgear are blurred frame by frame without affecting the visual quality of the PPE elements. This makes it suitable for both post-processing recorded footage or deploying in real-time video monitoring systems. The anonymization module has several strengths, is designed with privacy at its core, automatically identifying and blurring sensitive regions because it targets only specific objects like the head or helmet. It preserves PP information while protecting identity. It's lightweight and fast, making it usable in real-time systems or as post-processing tool. And finally, it's video compatible, supporting anonymization across entire video sequences. While the current module is effective, it does have a few limitations. Its accuracy lays on YOLO 5's detection, although it does fall back to glasses or helmets if the head is not found. It still cannot adapt the blur size based on image resolution or face dimensions. It only works on a fixed set of classes and lacks deeper redundancy through secondary detection. In the future, we plan to integrate an additional face detection module for better reliability, enable adaptive blur scaling, and expand to support full body anonymization. It is possible to make it work in real time compatible for edge devices like Jetson Nano.
Thank you, Amit, for explaining the PP anonymization. Now, I, Mohammed Sadiqul Islam, will discuss how we transform these detections into actionable safety reports through our AI-powered PPE compliance report. Before delving into our solution, let's understand why automated reporting is crucial. Currently, manual safety reports take 2 to 3 hours per site review. These reports often lack consistency in format and terminology, making them difficult to compare across different projects. Safety officers are limited in their coverage, and documentation is frequently delayed or incomplete. In addition, traditional monitoring creates adversarial relationship between the safety personnel and workers. Our solution is to detect non-compliance using the YOLO, use AI-detected non-compliance to create precise reporting using AI, provide standardized and professional documentation, and ensure compliance with generating documentation, maintaining the privacy and present regulatory requirement, and reduce reporting time from hours to minutes. Our report generation system completes the three-part workflow that actually previous teammates actually described, and the ChatGPT analyzes the data and generates comprehensive reports, which I'm describing here. And we especially use the ChatGPT for its superior capability in construction knowledge and safety regulation understanding. So our complete pipeline takes images from video from construction sites and processes them through several stages. After YOLO version 5 detection and privacy processing, we extract statistics on worker counts and PP compliance. This data is structured into prompts for ChatGPT, which generates detailed report text. We then compile professional PDF reports. For video analysis, our system provides frame-by-frame statistics and comprehensive compliance metrics over time, giving deeper insights than single moment snapshots. We used GPT 4.0. It accurately references OSHA standards, maintains consistent report structure, and processes data quickly enough for field use. Our comparative analysis showed it significantly outperformed the AI models for this specific construction application. This is sample output of AI-powered PP compliance report generator for image. This is the title page, and the title page contains the project title, the location, date, and prepared by. And the page one contains the executive summary of YOLO detection, PPE detection by YOLO, and also the PPE detection summary. Page 2 contains the AI generated safety compliance report. This output actually designed specifically by using the specific prompt so that we can get the specific outputs consistently. This is the report for the video, and this is the title page, cover page. The same. This is the page 1, which contains the executive summary and also PPE detection summary table. And the page 2 contains the report summary overview of finding and detected PPE items, and also the page 3 contains recommendation from you for improvement, conclusion, signing, and disclaimer. We do recognize limitation in our current implementation, higher API cost for using advanced models, internet dependency for cloud processing, the continued need for human verification, and pending regulatory acceptance as a standard documentation. This consideration inform our ongoing development and deployment strategy. Now I will hand over to our next presenter.
Thank you, Sadek. This is Srikanta, and I will now continue by discussing our risk benefit analysis, implementation approach, and the concrete accomplishment of our AI based safety monitoring system. As we examine the technologies powering our system, let's consider their risk benefit profiles. YOLO V5 or computer vision component delivers reduced manual inspection needs, consistent application of safety standards, and immediate alerts when violations occur. We have had to address challenges like false positives or negatives, calibration requirements, and managing computational demands. OpenCV provides our image processing capabilities with benefits including GDPR compliance, privacy preservation, and seamless stakeholder data sharing. The primary challenges here involve accuracy optimization, minimizing latency, and establishing proper governance frameworks. ChatGPT handles our natural language processing, enabling faster reporting, consistent documentation, trend analysis, and data-driven strategic insights. We continuously monitor for quality through human review to address occasional generic recommendations. Our implementation approach addresses critical safety challenges in construction by focusing on three key areas. First, worker well-being, ensuring the health and safety of all personnel on site. Second, maintaining rigorous safety standards through high-level safety protocols. Third, accident reduction, proactively minimizing incidents before they occur. To achieve this, we have created an integrated safety system combining three AI technologies: YOLO V5 for computer vision and object detection, OpenCV for advanced image processing, ChatGPT for natural language processing and reporting. This technological triad works harmoniously to monitor construction sites in real time. Our accomplishment: the core of our system focuses on PPA compliance monitoring through three interconnected objectives. We have automated PPE monitoring by implementing systems that continuously check worker equipment compliance without human intervention. We have ensured worker privacy protection by designing our system to maintain confidentiality during monitoring activities. Most importantly, we have created a safer work environment that demonstrably reduces workplace injuries. The benefits of our enhanced workplace safety approach include reduced workplace injuries through consistent monitoring, development of a stronger safety culture across construction sites, elimination of administrative burden through automation, overall enhancement of workplace safety measures. In conclusion, our AI-based PP compliance monitoring system represents a significant advancement in construction safety technology. By combining computer vision, image processing, and natural language processing capabilities, we have created a comprehensive solution that protects workers while respecting their privacy and reducing administrative overhead. We believe this system has the potential to transform safety practices across the construction industry, saving lives and preventing injuries. Thank you all.